International uses both Shepherd and TRW Ross Advanced Steering or TAS gears. In this program, we'll identify these brands and see how they work. We'll also look at different system designs. Unless a brand is specifically mentioned, the information presented here is an overview that applies to both brands of gears. Integral power steering means that the gearbox contains a manual steering mechanism, a hydraulic control valve, and a hydraulic power cylinder, all in a single compact package. The gear provides full-time hydraulic steering. Only enough manual effort to overcome the torsion bar and to turn the rotary valve is required. Integral steering gears are equipped with a rotary control valve, rotating valve assembly, actuating or input shaft, piston, sector shaft, bearing cap assembly, housing, slave gear on a dual steering system, and a steering column. Let's look at what happens during a steering maneuver. When a driver turns the wheel, he sends force from the steering wheel to the steering gear input shaft. The shaft is centered within the rotary valve by a torsion bar. The bar is pinned to the input shaft at one end and to the worm shaft at the other end. The bar turns with the input shaft and also forces the worm shaft to rotate. In response to this rotational force, the worm shaft, acting through the recirculating ball mechanism, tries to move the rack piston axially through the gear housing cylinder bore. This movement is resisted by the rack piston's engagement to the sector shaft, which is connected by a linkage to the road wheels. Because of this resistance, the input shaft twists the torsion bar, thereby actuating the control valve. The control valve directs pressurized fluid to help move the rack piston axially through the cylinder bore. The rack piston then turns the sector shaft to steer the vehicle. How fast the driver can turn the steering wheel using power assist depends on the pump flow directed to the cylinder. The pump flow is measured in gallons per minute, or GPM. The rotary control valve directs the flow of fluid through the steering gear. The more pressure a steering gear can withstand, the more work it can perform. The maximum operating pressure for the TRW THP PCF series is 2,688 psi at a maximum flow rate of 6 GPM, while the Shepherd M series gear is 2,175 psi at 6 GPM. Each vehicle manufacturer specifies the maximum operating pressure at which their various steering installations are to be operated. Refer to ISIS for the correct pump relief settings for the truck you are working on. If the truck is within its front-end weight rating, the steering gears can steer a vehicle through a turn at low vehicle and engine speed. As the driver turns the steering wheel faster or slower, the gear will require more or less fluid. It is possible for the driver to turn the steering wheel too fast, causing more steering change than is desired, which is called an oversteer condition. Refer to ISIS for TAS series front-end weight ratings. Let's take a closer look at how oil flows through the gear. When the steering wheel is turned, the actuating valve is opened in one direction. All the pressurized oil is applied to one end of the steering gear piston. This pressure buildup causes the piston to move. When steering stops, the gear returns to the neutral or non-steering position. Whenever the engine is running, there is constant low-pressure oil flow through the steering gear. The oil circulates at back pressure only and provides an instant response to steering wheel action, and also acts as a hydraulic cushion for the gear. For example, if the wheels receive a shock load, the shock is transmitted through the sector shaft to the rack piston and onto the worm shaft. The control valve sends high-pressure fluid to the correct cavity of the cylinder to absorb the road shock and help eliminate steering wheel kick. Most gears are equipped with two unloading valves, also known as poppets or plungers. There is one at each end of the rack piston. The valve in the direction of the turn will trip as the steered wheels come within 1/8 to 1/4 of an inch of the axle stops. These axle stops are factory set and should not require adjustment under normal circumstances. The tripped valve reduces pressure in the gear and helps to reduce heat generated by the pump. At the same time, the valves also reduce back pressure forces on the steering linkage. At the first full right and left turn of a newly installed steering gear, the poppet valves automatically set to the axle stops. Therefore, no further adjustment of these valves should be necessary. In addition to the poppet valves, steering gears are sometimes equipped with a relief valve, which limits maximum supply pressure at the steering gear. This optional part reduces system temperature by avoiding high-pressure bypass and recirculation flow within the pump. This is especially important when the pump is supplying pressurized fluid to an auxiliary component. It is worth noting that the relief valve does not reduce pressure as the wheels approach the axle stops, since this function is carried out by the poppet valves. Steering gears are identified by raised letters and numbers cast into the housing. In this case, the manufacturer is identified as R.H. Shepherd. The auto designation indicates a gear housing spec designed for plungers that adjust automatically. The serial number is stamped indicating the gear specifications and build date, each letter and number having a specific meaning. In this example, P means it's a powered steering gear, MX is the sequential model designation, and the number 3 indicates a gear spec with auto plungers. The numbers 06 mean the gear was manufactured in 2006, and the letter I indicates the month of September. 00944 is the sequential build number for this specific steering gear. Next is the TAS family of gears manufactured by TRW. Both the date code and specification number are stamped on the machined surface opposite the input shaft of this Model 66 gear. The date code 26906 means the gear was built on the 269th day of 2006. Newer gears include a serial number after the date code. An A at the end of the specification number, which is stamped above the date code, indicates a step bore housing. For proper replacement parts, always reference the steering code found on the vehicle's line setting ticket, or the international part number stamped at the bottom of the machined surface. When servicing other integral power steering gears, refer to ISIS to correctly identify the date code and specification information for each gear type. Having the proper ID will also aid the technician when requesting support from the 1-800-TECH line. Warning: bleeding of the dual steering system is critical whenever the oil has been changed, the system has been opened, or whenever a steering gear is replaced. Failure to bleed the steering system could result in an accident, injury, or death. Refer to ISIS for the proper bleeding procedures. 2 or more integral steering gears are sometimes used when there are high front axle loads. This is called a dual steering system. It's used to balance the steering gear output across 2 or more steering arms and conserve underhood space. In a dual steering gear system, both the master or left steering gear pitman arm and the slave or right steering gear pitman arm are mechanically linked to the front end components by a drag link and steer arm at each knuckle. The slave gear assembly does not have an input shaft or an actuating valve. Slave gears can become cold and sluggish in low ambient temperatures, leading to a possible complaint of noisy operation. The noisy condition is non-damaging and normal on severe service or heavy-duty vehicles that use 15W40 motor oil for power steering fluid. When the system is warmed up, the noise will dissipate. Pressure to operate the slave gear is passed through ports in the cylinder head, sector shaft bore, or bearing cap of the master gear. Fluid from the slave gear is returned to the master gear and back to the reservoir through pressure and return lines. When the actuating shaft of the master gear moves, pressure builds on its piston. This same pressure is directed to the opposite end of the slave gear piston, causing the slave gear to operate in the opposite direction of the master gear, assisting in the power steering operation of the system. The slave gear does not have hydraulic relief plungers. When properly adjusted, master gear relief plungers will relieve hydraulic pressure for both gears. When working on a Shepherd steering gear, it is important that the specified torque is applied to the retaining nut to force the pitman arm onto the sector shaft. This nut has the torque value stamped onto its face. In addition, ensure the tabs are bent into their locked positions. If too much or too little torque has previously been used on the retaining nut, the pitman arm and sector shaft must be replaced. On a TRW gear, a pinch bolt is used to secure the pitman arm to the sector shaft. Refer to ISIS for the proper torque value. There are three common dual system configurations with Shepherd M Series steering gears: cooling slave, 92 Series slave gears, and standard slave. The slaves operate the same way regardless of the configuration. There are two ways to plumb a dual system, depending on the slave gear. Let's look at some typical plumbing configurations. This is a typical dual M-Series steering gear layout. Fluid simply circulates through the gear when there is no steering action. Fluid only goes to the slave gear when the steering wheel is turned. Cooling slaves have a low-pressure return port cast along the length of the slave gear housing. Return oil from the master gear is routed through this port and back to the reservoir. The additional line provides a cooling effect, as well as using the slave gear as a heat sink. The 92 Series slave is plumbed the same way. Return oil is routed from the return side of the master gear through the sector shaft bore, then back to the reservoir. As with the cooling slave, the additional line provides a cooling effect and uses the slave gear as a heat sink. The M-Series standard slave gear requires only the crossover pressure lines between the master gear and the slave steering gear. An additional line is not required in the plumbing of the standard slave dual system. This concludes Program 2 of the Power Steering Training Series. Completion of this educational process is a key component toward International Technician Certification. You are now required to take a post-test via ISIS, Education, Service, online testing.